You want to be Web3 or blockchain developer, I will be giving you step-by-step tutorials to learn Web3. I know Web3 is really confusing as a beginner, but after watching my tutorial, it will be a piece of cake. So let's begin. Hey, Neeraj here. I teach Web3 development and sharing my learnings here with you. Hi, today you are going to build your first blockchain application using Hardhat and React.js. So get ready with your node installed. So in my previous videos I have explained how to do that, so you can watch that videos. uh, let's get started. The very first step that we are going to take is uh, we are going to uh, install create react app, and inside that we are going to launch our project. So npx create react app, and the name whatever you want to give in. Let us suppose we can give first dap. You can name it whatever you like. Let us create this. So it is going to install all the necessary packages that is needed to run react applications locally. As you can see, we have successfully installed our react application locally. We are going to head in that folder. My application was in uh, desktop, so I'm going to open it via VS Code. As you can see, we have all the packages installed. So to test it out whether your React app is working or not, what we can do is npm start. This command will start your uh, React application. Yeah. This is successfully installed, and we have React application running locally. Yeah. So so uh, Now the second thing will be we want to install all the blockchain packages to run it locally, right? What we are going to do is we are going to run a command npm I dash capital D dash or hyphen capital D, and you can say hard hat. Just click on enter, and it is going to install all the packages and dependencies needed for your local blockchain development. We have successfully installed Hardhat in our project, in our Ethereum project. Now we are going to initialize this Hardhat project in our React. So the command for that is npx hardhat. So we want to create a JavaScript project. Click on enter. The path will be the same. Click on enter. Yes, click on enter, and it is asking us that you want to install the remaining dependencies. Click on enter. So it is going to just wind up everything according to the React, and going to install extra dependencies like ethers and out of the box uh, to use consoles and toolbox for the hardhat. So have successfully created the hardhat project, and after running that particular command, you'll see they have given us a sample log solidity file and some scripts to deploy it, and we also have this configuration file and some test folder to test it out our smart contract. So first of all, let us head to um, hardhat config. We need to do some customizations over here. So this is a personal opinion. So let me just write it down and later come and explain it. So what command I have written is, to store all the artifacts whenever we compile our smart contract, it gives us the ABI. That I want it to be stored in the source folder. So here it is, the source folder, and the sources. from the source of the contract. So this is the contract source, this it is, and all the contracts ABI should be stored inside the source. This is what it does. It's a config that you can read more about in Hardhat official website. Now let us give up this default network as Hardhat, Hardhat, and networks Hardhat. We are just defining the chain ID. Chain ID should be 1337. So this configuration, whatever we did over here, it is mentioned in the Hardhat config, like in the files, in the website, in the official website of theirs. Now let us head to Solidity file. What we have here is the Solidity file, uh, I mean the smart contract that we want to keep use of. So just notice that this is using compiler of Hardhat 0.8.18 and 0.8.9. So what I want to do is like I want to keep up with 0.8.9, just because to avoid some compiler issues. Sometimes it gives the compiler issues if this Solidity version and the compiler Solidity version doesn't match. So keep that in mind. So when we are done with this, after that, what we are going to do is we are just going to write a smart contract that is going to get the user input and store it in the smart contract. A simple, very simple smart contract. So I have written this in advance. I'm just going to paste in over here and explain it one by one, that what it's going to do. This is a smart contract name lock. We haven't changed that, and it is taking an global variable as let me put this. I think this should, yeah, okay, yeah. So this is a smart contract local, called local, and it is a global variable that is unsigned integer 256 with the name of this, and I'll come to this later on. uh, just let me explain. um, this is a struct. So struct is also a data type in the smart contract, it's defined by struct and the name of the struct. So you can simply think of it as an object of a JavaScript. So it has the types. So address is the waiver, the string, the message type is string, and the timestamp should be is in uint 256. And we have an arrays defined of waves with the variable called waves. So this struct type is the whole thing will be as an array, as an variable as waves. So we have a constructor over here, and it is simply just console logging in to prove that we are inside the constructor, and the main thing starts over here. So what is this? So there are functions in the smart contract. The function name is wave, and it is taking an input of a string that is stored in a memory, and it is public variable. So public function. And as soon as it gets the message, what it will do is it will just update the total number of waves. So if you remember, we have total number of waves, and by default it will be starting from 0, and so we'll be having +1. So if a user comes in for the first time, it will be 1, excuse me. And what it's gonna do is like it is going to push inside the array, and it is going to store it as in struct. So if you remember, we have struct, right? This is a struct, and the struct, this is how we store a struct, just like a JavaScript object. And we are going to emit an event. So what are events? So I want you to quickly Google it out, what is events in the smart contract. uh, uh, what is event? It's like you can just emit an event, so to know for the front end architecture that there is something happening around this function. So this is very customizable. You have to just click on emit and name of the event. So as I said in the beginning, I'll come around this. So there is an event named new wave, and it has address index, so to filter it out from, and we are going to emit timestamp and string. So this is how we emit an event. Define an event name. So this is emit, the same event name, and whatever we want to just emit it. So these are the properties. So rest of them is very simple. Get all waves. So it is going to return an array of all the waves, uh, and get total waves means the total number of the waves that it has, I mean the numbers. So it is going to give you that. That's it, very simple. So now we are going to head over to deploy. So I've written the code for deploy as well, so going to give you that. By the way, I'm going to paste the GitHub link, so we will get access to all the codes, and you can just test it out on your PC, just I did, and it will be very interesting. So click on save. So now, what I'm going to explain here is we are going to deploy this script using automation, right? So because the world leads on automation, remember ChatGPT? Yeah. So uh, this is like HRE ethers. So we have ethers on the fly. As soon as we deploy this, uh, we are going to run it, and it is the name of the smart contract that we are going to import here, and we just click on deploy, and it will deploy the smart contract locally in our chain, in our hardhat contract that we are going to run uh, within a few minutes. And it is just testing it out, like uh, the smart contract, when it is deployed, get the total number of waves and convert console it log, and wait for the transaction to happen. And this is like this is the owner. The first address will be the owner itself. Second address can be uh, the second address that we're going to run. So let me show you that. And so to run anything locally on Hardhat, we have npx hardhat node, hardhat node. So it will run the local blockchain itself inside your computer, and it will behave as the same. So there are 20 20 accounts, and all loaded with 10,000 ethers, as you can see. So by default this get sinus gives the first account, and by default this will be the second, and comma you can just destructure the array. It is the array of the sinus. So this is what it is, and it is going to give you all the necessity things. Yeah. So I want you to run this command, and click on plus symbol if you are on VS terminal, VS code, and you can see this is running, and we are on the second itself, right? Second terminal. So uh, now what we are going to do is we are going to deploy our smart contract to our local blockchain, right? So to command for that is npx hardhat run scripts. Oops, scripts. Inside scripts, it's deploy. Yeah, deploy.js. How I did that? When you type in dep and press tab, it will automatically fill, and dash dash network, and it is in local host, right? So we are going to deploy this. Click on enter. Just wait for a second. Yeah. So I'm maximizing this. So as you can see, we have successfully compiled our smart contract, and the address which is deployed is this address, and we have all the consoles over here that we wrote in our deploy smart contract. So sorry, deploy script. So as you can see, previously it was still here, right? And this command, this blockchain was running locally. So as soon as we click on deploy it's see, this is the smart contract. I'm a smart contract. I can show you this, the log. Yeah, you can see the first thing that's get kicked in is the smart contract, this console log. So we have this, is that, yeah, I am console log, I am smart contract, the very first thing. And after that we have certain calls from deploy.js as in script. Here it is, we deploy, we got our console from the smart contract. And after that the contract address, we have this contract address, right? It is deployed here. This is the address where it is deployed. So how to link it from the front end and see whatever we have made, right? So we if you remember, the to run our React app, we need to run a command called npm start. So point to note here is the first terminal is running our blockchain that needs to be running in. The second one we compiled. You can just compile it over here and you can run simultaneously the React application over here. But what I like to do is, like, I used to just make a third terminal, and I keep separate for the React itself, and we can just simply run the React application over here. So let us see. Yes, it is successfully running and localhost 3000. And one more thing I didn't explain, I forgot to. So if you remember here itself, what we did is the sources from the contract and the output should be in the artifacts of source itself. So if you click on source, you can see the artifacts itself, right? So inside the artifacts we have this log.json, and inside this we have ABI files that we are going to use it in the front end itself, right? So let us do that. So head to source app.js. Okay, and inside this it is a simple app running inside, right? This is the thing that you see in app.js. So I did everything from top to bottom, the code itself in the front end. So I'm going to paste all the um, files in the GitHub itself, so you can download it, and I'll provide a link in the description. So this is the one. Let me just find it up. There is another file that is, I'm going to explain it. Yeah, sure. Just give me a second. That's CSS. Click on save. Click on save. Yeah. Now let me just compile it. All mm, contracts. Log.sol. Okay. Yeah. I think I did some mistake. That is not an issue. So yeah. So what it does is, like, this whole code itself, it is connecting to the local blockchain, and it will give you some output related to that. So first of all, you need to install the MetaMask. This MetaMask, you can just Google it, Chrome install MetaMask, and you will be presented with this. You can watch any kind of videos related to this. It's very simple. And for the local blockchain development, you need to install this. So now let us see what the application is all about. So first of all, we are going to ask uh, when you install Ethereum, sorry, when you install MetaMask, the first priority of the MetaMask is to get the accounts, your account, right? That 0x thing, this thing. Let me show you. So this thing, right? So 0fx and some hexadecimal number, and this is going to give up, right? And we saw the same thing on the ZSH, if you remember here, this account number, right? So this is account number, public address with 10,000 Ethereum, and this is the private key, and it should be personalized, but never use for this demo APIs, sorry, demo private keys for your production development, because it's for local development only. And if you lost funds, then you're gone, right? So if you're using those accounts, you're gone, you're screwed, man. So this object gets a window.ethereum. So in our window, it checks in that we have something in window.ethereum or not. And you need to know the basics of React as well for front end development of tap applications. So simply, this is a function that stores a constant itself, get Ethereum object, and this sees whether the in our window there is an Ethereum or not. So, and if you install MetaMask, you will simply get this Ethereum object. And if there is no Ethereum, then please console it. If it is, then please request an account number. I mean that 0fx hexadecimal hexa code that you saw in. And if we have all the accounts, then please store the first account to the accounts and leave rest of them, right? And it is storing in the local variable itself. Uh, yeah, and where do we call that? And we are calling it, let me, in the use effect, right? Fetch find MetaMask account, and it is going to get all the current accounts. Now the main thing is, when we are successfully connected to the MetaMask, when we are successfully connected to the MetaMask, when we wave something, it is going to store that particular data inside the blockchain, and it is going to show up in the front end, right? So this is how it is. So when you click on wave me, it activates a function called wave, right? And in this wave function, we have simple, if you can understand this in very logical way, when you're calling the API, you call it a function, and you use a fetch API to call that particular API, right? So instead of using that fetch API, we are going to use Ethereum blockchain that is running locally, right? So to do that, first we are calling the Ethereum contract itself, and contract address. So this is the contract address where we have deployed our smart contract. Let me maximize this. This is the smart contract address that it is deployed locally. So what it is a variable that we are storing it. Yeah. So we have stored the smart contract address here, and the second thing is ABI, right? So this ABI, it is stored inside the artifacts, and we are importing it above. So this is the ABI JSON, and here it is the ABI, and in this ABI we are just taking out from the JSON the ABI, and we are passing it in the contract. So these are the mandatory things that you need to pass to call a smart contract, whether you do it locally or whether you do in a production level. So but whenever we deploy our smart contract to the production level, we just do everything locally. So this is how you do it. This is the signer. Signer means that the account that is responsible for calling that particular contract, right? So we are so directly we are calling this particular contract, and we have linked everything. And in this, what we are going to do is like wave portal. So this is the access to the contract. We have all the access, and now get all waves. So what is this get all waves? This get all waves is the function this function. Yes. So this function of the smart contract that we are calling from our front end. So that is the process uh, that you do it from the front end, and it is going to give you all the waves that is there in the smart contract as a storage, right? Similarly, what we are going to do, we are going to just call the smart contract with the same functionalities as I explained, and after that, here we are just simply seeing that how many total waves are there, the same smart contract function, and after that here you can see we are calling wave function, right? So in this wave function, we have this wave function, and it is taking up a string message, and memory is a property of a smart contract, and you need to follow this. It is going to implement one, and later on it is going to emit, and it is going to push in the smart contract as an array. So it is calling a wave function with a string, and it is waiting for the hash to happen. So in the API, what happens is like it is also async and await, right? If you store it in Mongoose or MySQL, server takes some time. So instead of server, you can think of it as an uh, blockchain, Ethereum blockchain, that is uh, keeping those data safe, and it is waiting for it to be the mined. And when it is successfully mined, the miner is rewarded with rewards Ethereum, and the transaction hash is generated, and this is the hash that you are waiting for, and it is waiting. So that's very simple smart contract, and according to the React logic, we have just implemented everything. It is like to get all the waves, we are storing it in local variable, and it is returning everything. uh, it is returning the address, time, and message that we have inside the smart contract array, right, in the struct itself. So you need to know the basics of JavaScript, React.js for sure to be in Web3 development, but just the basics of it, not too advanced, but you need to know it because it uses JavaScript a lot. Yeah. So let's see how this demo looks, right? So let me just open inspect element because we have so much going on inside our console. And yeah, one more thing that I wanted to show you. When starting up, when you just installed the MetaMask, for me it is local 8545. So how to do it? So when you click on this area, you will be shown up with several test networks, and you need to click on localhost 8545. So it will automatically connect you to the localhost 8545. But what we want to take this step further, and click on import account, and you see it is asking for a private key, right? Private key string here. So if you remember that we have our local host with our own private key and all the Ethereum's put in, right? So I have imported the first account, but let me show you for the second account. So this is the private key, right, for this particular account. And if you click on Control C just to copy it, and if you paste in here this import, you see the magic, the account tree is there, and with almost the 10,000 ethers, right? So you can just click on account details and edit just to remember which account it is. HARD hard hat second account. Yeah. So if you click on this icon, you have all the accounts that you have saved in. So I have imported the first one, but the second one is imported in front of you people. So you can see the second account is there. So let's test it. It is not connected, right? So let us reload this. This is 70 ending with 793C8, right? 79C8, sorry, 79C8. So it is connected to this account. And now if you click on wave at me, it is going to invoke a smart contract. So it is going to ask you about the confirmation, whether this is to be done or not. So it is asking you to confirm and sign the transaction. Yeah, so you can see we have successfully done this transaction, and it is mind evil. And if we click on refresh, so you can just put uh, uh, a feature that as soon as it mines you can just see this is 13.8, and itself is 13.8, and it is this just showing you from the smart contract. So it is a whole data is coming from the smart contract itself. So let me show you. So you are running a local Ethereum itself here, right? So here you can see that it is calling those Ethereums, and it is from and to the smart contract itself. So hope you get it. So let me just I showed you all the steps how to build your first dApp or blockchain application. It's a very simple. You can just organize it, or you can just uh, add on the features to send Ethereum contract something else. So let me just so what we did. So what we did is, yeah. So what we did is this is the smart contract, and we wrote this smart contract, and from the front end, from our React application, we build a button such that it is going to invoke it. So this button, wave at me. If you look at this wave at me, what it does is like wave at me, wave at me. It is what it is doing. It is just simply calling the smart contract. Here it is. We build our smart contract, and we wrote it down, and it is calling this wave thing, and it is waiting for the transaction to happen. And inside, if we look at the wave, it is going to push all the things, and it is going to give you. And now whatever thing that you wrote in, as you can see, we wrote what we wrote. Yeah, this is a message, right? This is a message, and here it is. This is a message. So it is coming from the blockchain itself, and give a pack to your back that you have built your first it's very impressive that you have built a first smart contract locally, and very easily. So I'll paste all the links in the description, the GitHub link, so you can just come and you can just practice your own blockchain development.